Patella flavescens is called the global wanderer, and it's a really good common name for it. I've collected it in New Jersey, I've collected it in Arizona, I've collected it in Texas, but I've also collected it in Australia, in South Africa, and Namibia. It's one of those taxa that you can get pretty much everywhere you go. My name is Jessica Ware, and I'm an associate professor here at Rutgers University-Newark. And we have this termite database now started. I'm an evolutionary biologist, and specifically I study insects. So I study how, when, why, and where insects evolved. We need to have insects so that we can have food because they pollinate our food. We need to have insects because they do all sorts of services for humans that are kind of behind the scenes. But we also need to have biodiversity because that's what drives communities, that's what keeps the earth kind of functioning. So population in science really means a group of organisms that are breeding together. And that can be over vast expanses of space, or it can just be in a single pond. Dispersal and migration affect the populations because, for example, in Pantala, which is a dragonfly that migrates around the world, huge swarms of these individuals leave an area. They leave India, for example, and fly across the Indian Ocean towards Eastern Africa. So population number and size can vary seasonally. We'll pull out our dragonfly. During the winter months, we have a lot of time when we're doing molecular analysis. Dragonflies are great because they have a huge amount of DNA in their thorax. When we tried to look at whether or not Pantala were present worldwide, we ground up their DNA and tried to get DNA sequences from a bunch of different locations. By far, most of the individuals from all of these countries are sharing their DNA, which means that they're breeding, which means that for Patella flavescens, the whole world is one giant population. The DNA will float into this. We might see one large continuous distribution of individuals in a population now, but we can see the history of past isolation by looking at their DNA, by looking at their genetic imprinting. There's two evolutionary processes that humans can study. That's natural selection and genetic drift. Natural selection is the one that people have heard about. Genetic drift is the other piece. Genetic drift is an evolutionary process that has a really strong effect when populations are small. It's random processes that lead to mutations which arise or mutations which are lost. That's the process of genetic drift. We study populations because we're interested in gene flow, we're interested in dispersal, we're interested in variation among individuals, which natural selection can act on. But also, when populations are really small, they're more prone to genetic drift. We know that with habitat change and habitat loss, species are being lost, biodiversity is decreasing. And so it behooves us to study what drives speciation, what drives the formation of new species, and what drives extinction. So when we look at insect collections, that allows us to see how populations of insects may have changed over time, in their appearance, but also in the distribution, where they're found. It can tell us about whether or not it was more common to collect a specific species in a location than another species. These collections are like snapshots in time. I like knowing that this, on the 9th of November in 1997, this damselfly was flying near a small stream in Ecuador.